Hello everyone, my name is Sakshi from Pandit Deendayal Energy University, representing from Team 6. This project is about disk scheduling algorithm in operating system, which is created under the guidance of Dr. Chaudhary. This project is created using HTML, CSS and Bootstrap as front-end and JavaScript as back-end. This is our team of 6 members. So now first let's understand what is the need of disk scheduling algorithms. Disk scheduling algorithms are needed because a process can make multiple input-output requests and multiple processes run at the same time. The request made by the process may be located at different sectors on different tracks. Due to this, the seek time may increase more. These algorithms help in minimizing the seek time by ordering the request made by the processes. So, let's see the structure of disk storage looks like. A magnetic disk is the easiest way to implement the secondary memory. Each disk platter has a flat circular shape like a CD or DVD. Both the surfaces of the platters are covered with magnetic material. These are headers on both the sides of the platter and hence read and write operations can be performed on both the sides. The surface of the disk is divided into circular tracks. These tracks are further divided into sectors. Seek time. It is defined as the time required to move read and write heads on the desired track. So now let's move to our website. This is how the home page of our website looks like. Here we have included intro and certain terminology of disk scheduling algorithm. Certain terminologies are seek time, rotational latency, transfer time, disk access time, disk response time. Seek time we have already discussed earlier. Rotational latency is the time taken by the desired sector of disk to rotate into a position so that it can access the read-write heads. Transfer time. Transfer time is the time to transfer the data. It depends on the rotating speed of disk and number of bytes to be transferred. Disk access time is the seek time plus rotational latency plus transfer time. Response time is the average of time spent by the request waiting to perform its input-output operation. Now, let's go to our first algorithm, that is first come, first serve, and we have added advantages and disadvantages of each with its definitions. FCFS is the simplest of all disk scheduling algorithms. In FCFS, the requests are addressed in the order they arrive in the disk queue. Let us understand it with the help of an example, which we will discuss further in the video. Our next algorithm is shortest seek time first. In SSTF, requests have shortest seek time are executed first. So, the seek time of every request is calculated in advance in the queue and then they are scheduled according to their calculated seek time. So, request near the disk arm will be executed first. The further algorithm is scan. In scan algorithm, the disk arm moves in a particular direction and serves the request coming in its path, and after reaching the end of the disk, it reverses its direction and again services the request arriving in its path. So this algorithm works as an elevator and hence also known as an elevator algorithm. As a result, the requests at the mid-range are serviced more and those arriving behind the disk arm will have to wait. And our last algorithm is look. It is similar to the scan disk scheduling algorithm except for the difference that the disk arm is split off going to the end of the disk, going only to the last request to be served in front of the head and then reverses its direction from there only. Thus, it prevents the extra delay which occurs due to unnecessary traversal to the end of the disk. Out of all the algorithms, scan and look are the most efficient due to lesser time seek than the others. At last, we have embedded one YouTube video to understand thoroughly about disk scheduling algorithms. Now, let's move to our simulation part. Here, full algorithms are implemented. To execute each, we must select one by one and calculate further. Without selecting any algorithm, if we try to input values and calculate it, it will give an alert. For example, we are selecting inputs as 110, 23, 75, 130, 190 and 11. The head position we are selecting is as 100. If we will calculate, it will give an alert. Also, negative values will also give error. First we will select FCFS and input values and head positions will remain same. Further, if we will click on calculate, a graph will be displayed which shows the visualization of algorithm. According to FCFS, graph will start from head position and moves further to next point which comes first in queue respectively, and at last total head movements are 423. Range of each graphs in further algorithms will also be in between 0 to 199. Next algorithm is shortest seek time first, which is also known as SSTF. Here we will take same input values in the queue to get the graph. According to SSTF, first graph will start from head position and move further to the point having shortest seek time. Total head points here are 268. Our third algorithm is scan. Using same input value, simulate this algorithm. To get the graph, click on calculate. Here, head starts from one end of disk and move towards other end, servicing request in between one by one and reach to the other end. Then direction of head is reversed and process continues as head continuously come back and forth the access disk. Here the total head movements are 287. Our last algorithm is look. Look algorithm is the advanced version of scan. Again the same input value, calculate it to get the graph. The graph shown here shows that if there is no pending request in moving direction, the head reverses the direction and starts servicing request in opposite direction. Here the total head movements are 269. As we can see, the head count of look algorithm is least, so it is the most efficient among all the algorithms. This is our about page in website. So guys, this is an end to our video. To know more, you can find our source code in GitHub link given in the description below. Thank you for watching this video.